An OR gate produces a high output when either input is high. This switch represents our first input signal. We call this input A, and a second input switch for the other signal. We call this input B. The OR gate is the heart of our circuit, implementing logical disjunction. This is our logical OR operator. This connection routes input A to the first input pin of the OR gate. Input B connects to the second pin, completing the input stage. This light will visually indicate the logical output of our OR operation, labeling our result. The gate's output drives the indicator light, making the logic visible. Encouraging experimentation is key to understanding. This summary captures the essence of OR logic. Let's examine our input stage closely. These switches control the binary inputs to our logic gate. Now we see how the inputs fit into the complete circuit. The OR gate performs the fundamental logical operation. This component implements the logical disjunction of its inputs. Let's see how this gate connects to the rest of the circuit. This indicator reveals the result of our logical operation. The output state directly reflects the OR gate's decision. Here's the complete circuit in its entirety. Watch how the signal flows from input to output. This is the path electricity takes through our logic. Activating the first input demonstrates a fundamental case. Notice how a single high input produces a high output. The complete picture shows the signal propagation. Let's examine the gate's decision-making process. The gate evaluates both inputs and produces the logical OR. Back to the full context. Now we test a different input combination. With only the second input active, the gate still produces a high output. The alternate path demonstrates the OR property. Either input alone is sufficient to activate the output. The symmetry of OR logic becomes clear. Finally, we activate both inputs simultaneously. Both inputs high produces the expected high output. The entire signal path lights up when both inputs are active. We've explored all possible input combinations. Resetting to the clean state. Understanding OR logic is fundamental to building complex digital systems. This simple circuit embodies a powerful logical concept.